Hello community! How not to start with AI? Welcome to part number 2. So today we connect your company AI, your fine-tuned AI to external data. This is where we left off, and I said, hey, you have now a fine-tuned AI, and then you want to connect to your database, to a data lake, to a delta lake, to a keyword research engine, a vector embedding search engine, or some sensor data. So now let's start at the very beginning. Imagine you have your generic AI, you have a pre-trained LLM, either open source or you pay for it, never mind. Then we fine-tuned this pre-trained LLM for a specific task. Think about this. This was the first car, the very first car invented, and now we fine-tuned it for a specific task, and the task is to be an ambulance. So you have a specific functionality within the car, a medical functionality, and maybe the car should be also really fast given the velocity of the car. Or you go for another task. The task is move as many people as possible from destination A to destination B and be economically viable. So you have a bus. So depending on your specific task, you create here, or you want to have specific models. Great. Now, those models, they have to interact with the environment. So whenever the ambulance arrives here at the hospital, it makes sure with the data communication that the right people are waiting at the emergency entry here for the patient, that maybe an ICU is already reserved, that the people have been notified that there might be here a medical intervention happening. So you see integration and external data. The same with the bus. If the bus arrives late at the bus depot, do you miss your connecting bus? Do you miss your connecting flight to an airport? You see, always you are interconnected to some external data network in real time. So this is what we're going to focus today. Great. So we fine-tuned our own company AI, and you see the whole world is fine-tuning their specific model. Fantastic. And as I showed you last time, in principle, we have 3 steps. We have our pre-trained open source LLM. Great. Then we have here, for example, the Hugging Face supervised fine-tuning trainer module that does the fine-tuning for us on our data set. And then we align our model for a certain behavior, or if it interacts here in a complex environment, we have here maybe, you know this from OpenAI, the PPO policy optimization, and we have reward function, or you go with the more advanced DPO. Great. I received questions from my viewers about instruction tuning. Is this fine-tuning, or is this ICL? Is this prompt engineering? What is instruction tuning here in this framework? Easy. Instruction tuning here is like fine-tuning your pre-trained LLM if you have a huge data set available. So we have here a tuple with an instruction and an output, and if we have a static data set, you can fine-tune your model here very easily. However, there's also the option that you use instruction tuning as a reinforcement learning method. What's the difference? If you have a clear data set, labeled examples, immediate performance on this example is the primary goal. So you have a large language model, for example. The goal is to generate technical reports. You can train it on a huge data set of existing high quality reports. So instruction tuning via fine tuning. However, if you have an interplay with a more complex environment, when the system needs to adapt dynamically to complex environments and sequential decision making, you can use reinforcement learning, PPO, DPO here, and it is better to learn strategy because you have reward functions and so on. So for example, to train a chatbot to improve the customer satisfaction here, through interactive dialogue with your customer, the bot learns here the best responses over time based on the feedback from the customer that call in. So you see, Instruction fine-tuning, you can have it here with a precise static data set in fine-tuning, but also in reinforcement learning. However, when the policies are too complex to learn, we have other ways. But yeah, let's focus on this answer. Great. PEFT, LoRA, you know this. LoRA is just one method of PEFT, and PEFT stands for parameter efficient fine-tuning. So the question is, PEFT LoRA a fine-tuning? Yes. You have here the full fine-tuning or the parameter efficient fine-tuning. If it helps you, think about P as partial fine-tuning, where only the injected weights here in our trainable tensor weights. Those are the videos for you. Great. So let's come back. We have an AI, we have it fine-tuned on the task, and now it has to interconnect to a real-time data network. Either the complete internet or just your company database or whatsoever. So which model should I buy was one of the questions of my viewers that asked me here in the last video. Well, it's easy. You have options. Let's have a look at them. Companies sell their trained large language model. And they have here the complete structure here. You have a simple pre-trained, then you have it fine-tuned, then you have the behavior aligned here with a specific method. So you have here complete models for fintech, for medtech. So companies sell their models that they have trained for a particular task on a particular data set. Now, normally you don't know the data set that they have been trained on, neither this, or this data set. So you have no idea, you just get something and you can't be sure that it really fits your job, your task, your downstream task. Therefore, some companies sell only their pre-trained LLMs. You know, our example, when we have here an English pre-trained LLM and the task is French poetry, you know that this pre-trained LLM is not the best choice. However, you can take those pre-trained LLM and you can fine-tune now this preset LLM with your company data for a particular task. Either only fine-tuning or even aligned. It's completely up to you. You just take here this pre-trained LLM and you do the fine-tuning on your company dataset behind your firewalls. Or you can go also to a cloud infrastructure. So you have the option here, train the LLM on your local computer infrastructure or on a commercial cloud infrastructure. It's up to you. Great. Now, there is, of course, in the business-to-business transaction that, like ChatGPT or GPT-4 or upcoming GPT-5, you have a black box LLM. This, what we know from the open source, suddenly becomes this as a proprietary system by OpenAI or by Microsoft. So, this is now a case where you say, how do I integrate here real-time data from my company? Let's look at this. So what we have our cloud AI somewhere, OpenAI, GPT-4, whatever you have. And then more or less you only have two possibilities. You have a prompt structure or you have an API that is given to you as an I/O interface. And then you have your local company data. All the data, structured, unstructured data, whatever you have. And you have only two channels because this is not an open source, but this is a proprietary black box for you. So how we do this? This is an age-old question. So you have your cloud AI, let's say from AWS. You have bought there the place and the compute units. And here you have your old-fashioned database here in your local IT infrastructure. And you have a question, you have a task, and you say, hey, GPT-4, whatever you have, when did my company reach the first 1,000 customers? Now, GPT-4 says, hey, I have no idea. So I have to go out and I have to contact somebody who knows. And since you ask here this and you established here a connection from your company data to GPT-4, what happens is GPT-4 says, hey, I have to ask your company for this data. Now, let's be a little bit more specific. Your company data are in your local database, in your local data lake, in your local Delta lake. You can perform a keyword search on your document servers, or you have maybe the latest here, a vector search on your documents. Great. Let's look at this maybe in a little bit more detail. Here we go. So the easiest thing is GPT-4 says, hey, I know that you have a database, a financial database, a customer database. So I write now as GPT-4 a SQL prompt, and I prompt here your database because I have access to your company data. I write a SQL command, the database recognizes the SQL commands, searches the database and gives me back the result, and the result is here. The July 17, 1972. My goodness, you are an established company. This is the exact time you reached 1,000 customers. And this result here is fed back into GPT-4, and GPT-4 does now a very nice sentence with this. So GPT-4 comes back and says, hey, you reached your first 1,000 customer on this particular date. So you see, this is the interaction. GPT-4 can talk SQL, NoSQL, SQLite, or whatever language to interact with your databases. If you have a very specific database, no problem. We have AI systems that are trained on hundreds of different database structures and access commands and access codes. So GPT-4 calls here its little brother a SQL AI that is specialized only to access databases. And then this sends off here the command. The database receives here its native command, operates the command and gives you back the result. And this is perfect. Great. Yeah. One of the questions you sent me is, hey, should I convert my company database to a vector embedding, to a vector space? The answer is no, and I give you a simple reason for this. Think about this. Amazon. For example, my address is, if I order something at Amazon, is Austria. Now, if, for example, now the database, a structured relational database, is converted now into a vector space, and in this vector space, the numerical values of the database are interpreted with a particular tokenizer and with a specific semantic similarity functionality. Now, hundreds of millions or trillions of numerical values are structured in ways nobody has any idea about. And maybe it happens that instead of Austria, my package is sent off to Australia because there sounds really similar. And statistically, hey, there are more people that can order at Amazon in Australia. Australia is a much bigger country. Australia has much higher temperature than Austria. So statistically, hey, in this vector space, yeah, it makes no sense at all. So please do not convert a database with numerical values to a vector embedding to get some key specific value data back. It's the reason it's a database. Databases are so intelligent. And you want that the address is not changed at all, not at one single character. Beautiful. Next, unstructured data. Whatever you have in your documents, you know, these are official here from the last meeting of the Board of Governors here. This is the protocol. And it is just a Word document, a text document, whatsoever. So you have your trusted documents, your documents or whatever infrastructure you have from the 1990s here with magnetic tapes. And you see here, hey, what a beautiful infrastructure proven for 3 decades. Great. And then you implant a brand new AI system here, a quantum computer here in your classical IT infrastructure. And you might ask, is it possible that some computational incompatibilities could arise? Yes. So let's assume you have your unstructured data not in a data lake, but you are an advanced company, so you have it in your Delta Lake. If you do not know what a Delta Lake is, it is an open source software that extends here our Parquet data files here with a file-based transaction log for some ACID transaction and scalable metadata handling. This is what you need for compliance to QM to everything. So your unstructured data, hopefully in a Delta Lake. And the company that does this, originally invented this, is Databricks. Great. If you want to have an understanding what is Databricks, it is an AI and data company. And go there and you see here the benefits of retrieval augmented generation, or should I fine-tune the model? Now, first part 1, was on fine-tuning the model. And now here those expert people ask, hey, in what circumstances should I not fine-tune the model, but when should I use RAG? Read it, it's really interesting. And this is what I want to show you here. On December 6th, Databricks came out and said, hey, exclusive, we have now finally created tools for building production-ready, high-quality RAG apps. So now, finally, after quite some time, December 6, 2023, we have now high-quality RAG application that is really, if I would trust one company to do RAG professionally, in my personal opinion, it is Databricks. So now I would be willing to go here on a production-ready RAG application with Databricks in a Delta Lake. Yeah, it is about the lakehouse monitoring, about the new Unity catalog, about whatever. Please notice that just here, the senior director here of product tells us at December 6th that organizations currently struggle to deliver solutions that consistently deliver accurate and high quality responses if they apply here our RAG, our retrieval augmented generation. So RAG is far from being solved, far from being perfect. Organizations struggle to deliver solutions that constantly deliver the accurate and high quality responses. And now Databricks says, now we have found a solution. Have a look at this. It's great. If you do not know Delta Lake here, now this is here an early release for a little booklet to be released in 2024. You can download it for free. This here is the PDF link. And there you have, I don't know how many 100 pages. You have here the complete code, and each code explained in detail how you can build a data lake, how you can transfer your data lake to a Delta Lake for all your company unstructured data that you do not have here in, for example, SQL databases. Great. Yeah, I have here videos that are more than a year old where I showed you how to go from a warehouse to a lakehouse, Spark, PySpark. This is just if you are interested in this topic. So beautiful. So now from the Delta Lake, we get a response. The Delta Lake RAG here by Databricks gives us now back a particular tiny bit of information that we feed back in a prompt, and the AI system will use this particular sentence or paragraph of information. Great. Now, if you have a document server, a keyword search is still beautiful. I use it all the time. I use the Google search functionality that is based here on a keyword search functionality, and I will show you why it is still valid. However, you know that there is now the latest kid on the block, Cloud AI and vector embedding machines, vector stores. So let's talk about this. When should you do a keyword search? And when should you do a vector search on your company data? And I was asked, hey, why do I use this? Easy. Let's say I have two documents, just for explaining the principle. Now, the first document, it is talking about here 4 specific terms, and in the second document, I have just an acronym. Now, then in this document, I have here this explanation, and in the second document, I have here this explanation. Now, if you look at this and you do a keyword search and you do not get that ACID is the acronym for this, then I need the semantic similarity of all of those text paragraphs to find out, hey, those two paragraphs are talking about the same thing. And then, if I build a vector space and I build here the vector embedding of acid and the vector embedding of those four words, I will notice that those embedding, those vector representation in this particular vector space are really close. So now in this case, a vector search is helpful if I do not know that these terms refer to these terms. However, if I just put here in this paragraph, hey, it's also called acid, then the keyword search would be sufficient. So you see, the structure and the semantic content of your documents define if you want to go with a keyword search or a vector search. And just because a vector search is currently hype, it does not mean you have everything to convert to a vector store. Beautiful. So when do I really convert it to a vector store? Let me give you an example. I have here a biochemistry publication, and now imagine this text is about 136 pages. And here I have about molecular science, so this is chemistry, this is theoretical physics, and here it's close to 98 pages. And now I want to understand if in chemistry they use more or less or different methodologies than they use here. And it is about similar topic here, molecular science, and here biochemistry. And we look here at protein structures and their functions. And here we look at the molecular structure. So what I do now is to compare here hundreds of pages. I create now with this particular data a mathematical vector space based on the semantic similarity of the text of the input data sets. And I have here, for example, an S-BERT system, a sentence transformer. And I do the same here for my physics text. Now this text here is now converted in the vector space in 3 vectors. You see, it's a simplification that is beautiful. Because now I know that the first vector is mass spectrometry, the second vector is X-ray crystallography, and the third vector is nuclear magnetic resonance spectroscopy. Beautiful. So if I do now a vector search in a local neighborhood, let's say here on the X-ray crystallography item, in a newly constructed vector space, and I look for terms, I don't have to go through thousands and thousands of pages of text. I just go here and I look here in a local neighborhood what vectors are in the local neighborhood. This is vector search of embedded vectors. This is beautiful. It is fast and it is gorgeous, but you don't need it every time. However, if I compare this now to physics, also chemistry to physics, I see that in this particular document, I still have the same vector, X-ray crystallography and mass spectrometry, but in physics, we do not use here in this particular application the nuclear magnetic resonance spectroscopy. So here I can say, hey, wait a minute, if I want to work interdisciplinary, why not explore here if this methodology would be helpful here in physics, given that they use it in chemistry. So you get the idea. However, if you do not train here the best tokenizers to create your vector space, if you do not have the best vocabulary structure for your given input text, this can happen. Your biochemistry text generates quite different vectors. They're all right, and they're all about proteins, processes, biochemicals, molecular, all beautiful. But they are not focused on the task that I want for the methodology, but they focus on something else. So we get a different vector embedding, a different vector representation in a different vector space. That is scientifically correct, but it's not helping me with my task. This is why I tell you, if you build vector spaces, you have to build harmonic vector spaces, or as I call it, coherent vector spaces. Otherwise, you cannot compare this to this vector space. Some days ago here, Yannick released a new video, YouTube video. Go there, like him, give him a subscription. Text embeddings are not safe. And he looks here at a particular study here from Cornell University, October 10, 2023. And this research team discovered that the text embeddings reveal almost as much as pure text. So if you think that your text embeddings are somewhat encrypted now in a vector representation, guess what? The researcher found a way to resurface more or less your text from your vector embeddings. So another argument that you should not always use vector stores, and be careful if you do it and you put it somewhere on a cloud. Beautiful. Cornell University tells you, hey, vector databases are increasingly popular, but the privacy threats within them have not been comprehensively explored. And this is a scientist telling you this. So imagine how this would be on a social media platform. Great. Yeah, I have a video after RAG, after vector stores, and after GPT stores. I showed you new technological possibilities coming up, but are currently not, how to say this, financed by a venture capitalist, where you have tens of millions for marketing, for building up a vector store brand. So this is before the hype. This is still here with the RAG hype. Great. So we have it. This is it now. And now you know when to use vector search with your vector embeddings, how to construct vector embeddings that are coherent to your input data set, and when to simply Google your search or have a simple keyword search that is also as good and as fast if you have the right algorithms. Beautiful. Yes, I know. If you have now with a context length of our LLMs are continuously increasing, 50K, 100K, 200K token length here of your specific prompt. So you have a vector search and you can almost put back whole chapters of books. But you know there is some other research that tells us, hey, if you fill up here the complete prompt, you know that the AI system just looks here at the primary attention at the very beginning of the text and the very end of the text. And what is in the middle of the text, there is a probability that the AI will not read the middle. Great. Beautiful. So now you understand that I use this here not to the maximum context length, but if I do some research on a database, on a Delta Lake, I try to keep it short pieces of information. Then you have a higher chance that a complete answer is accepted and read and processed by your proprietary black box LLM. Beautiful. Now you know exactly what to do. Now you know the pros and the cons for all the different external data connectivity to your AI. And here you have it. This is it. Part 2 finished. Connect your fine-tuned company AI system like an LLM system or a vision language model system to real-time external data. Now you know how to do it. It would be great to see you in my next video.